So, if you're building anything on AWS, there's one decision that's, well, bigger than almost any other: picking your database. I mean, get it right and you've got a rock-solid foundation for your app. Get it wrong, and you're pretty much building on sand. So today, let's draw up a clear blueprint for making that choice. And look, this isn't just some abstract technical question, it's a huge strategic one. The database you choose today, it's going to define your application's performance, how it scales, and what it costs for years. It is literally the difference between a project that soars and one that just doesn't. Before we even get into specific AWS services, we have to start at the beginning, the most fundamental choice in the entire database world. It's the big fork in the road that decides everything else. Are you going with a relational model or a NoSQL model? Let's make this super simple. Think of a relational database like a set of perfectly organized linked spreadsheets. Every row and every column is defined, and all the relationships between them are super strict. A NoSQL database, though, is more like a filing cabinet full of individual folders. Each folder can hold whatever you want. Different kinds of info, flexible formats. There's no rigid schema you have to follow. Okay, so let's say your app's data fits that linked spreadsheets model perfectly. You need that structure, you need that consistency. Well, AWS gives you two main managed services to think about: RDS and Aurora. First up, you've got Amazon RDS, the relational database service. Honestly, this is your industry standard, totally battle-tested choice. It takes the database engines you already know, like PostgreSQL, MySQL, or SQL Server, and just handles all the annoying stuff for you. We're talking patching, backups, redundancy, the whole deal. It really is the reliable workhorse for a massive range of applications. But what if you need more than a workhorse? What if you need a thoroughbred racehorse? That is where Aurora comes into the picture. Aurora is basically AWS's complete reimagining of what a relational database could be, built from the ground up for the cloud. Now, it's compatible with MySQL and PostgreSQL, but under the hood, it gives you these huge gains in performance and availability. It's not just RDS with some extra fuel, it's a whole different kind of engine. So, where do these relational databases really shine? Okay, picture a SaaS app that handles things like billing, user accounts, and inventory. You need absolute, rock-solid data consistency, right? A payment can't get processed twice. You have to run complex queries to generate reports. This is the absolute textbook use case for a relational database like RDS or Aurora. All right, let's hit rewind. Back to that fork in the road. Let's go down the other path this time, into that flexible file folder world of NoSQL. And on AWS, the undisputed king here is DynamoDB. The first thing you have to know about DynamoDB is one word: speed. And I don't just mean it's fast, I mean it's consistently fast. We are talking single-digit millisecond response times. And here's the kicker: it stays that fast whether you have one user or 100 million users. That level of performance, at any scale, is its absolute killer feature. You see, DynamoDB is what you'd call a purpose-built tool. It's a fully managed NoSQL database that's just fantastic with key value and document data models. AWS literally built it for one reason: to power modern apps that need to handle insane amounts of traffic without even breaking a sweat. Think about the perfect places to use it. An e-commerce shopping cart? It doesn't need a bunch of complex relationships, but it absolutely needs to be lightning fast and handle millions of people during a flash sale. Same thing for a real-time gaming leaderboard, or for storing massive volumes of user session data. For these kinds of high-velocity jobs, DynamoDB is the champion, no question. Okay, so we've got our two main paths: the structured relational world of RDS and Aurora, and the flexible, super-fast NoSQL world of DynamoDB. So now for the fun part. Let's put them head-to-head on an architect's scorecard so you can really understand the critical trade-offs you're making with each one. This whole complex decision really boils down to four key areas. First up, consistency. RDS and Aurora give you strong, immediate consistency, which is absolutely vital for things like financial transactions. DynamoDB, on the other hand, gives you what's called eventual consistency by default, which prioritizes speed and being available. Second, scaling. With RDS, you scale up, you just get a bigger, more powerful server. With DynamoDB, you scale out. You just add more servers, which means you have practically limitless scale. Third, operations. Now, they're both managed, but DynamoDB is truly serverless. You just set your capacity and you're done. RDS needs a little more hands-on work managing the instance. And finally, Cost. With RDS, you're paying for that server by the hour, whether it's busy or not. With DynamoDB, you can pay per request, which is perfect for spiky, unpredictable workloads. So with all those trade-offs in mind, how do you actually make the call for your next project? Let's take all this info and distill it down into a simple, actionable checklist you can use every single time you have to make this decision. Here it is, the 5 key questions that make up your blueprint. Number 1, structure. Is your data structured and relational, or is it flexible? 2, scale. Are you going to need to scale up to a bigger machine or scale out to many machines? 3, latency. Is that single-digit millisecond speed a non-negotiable must-have? 4, consistency. Does your data need to be perfectly accurate, immediately, all the time? And 5, queries. Are you running complex queries with lots of joins or just simple lookups? I promise, if you answer these 5 questions, they will point you to the right database every single time. And there you have it. That's the architectural blueprint for choosing your most foundational service on AWS. You get the core trade-offs, and you've got the checklist to make the right call. The foundation is set, so the only question left is, what are you going to build on it?